K-16B students, here is the video of the writing solutions to the practice file I posted. All right, let's get going. Yeah, so always good to read the instructions. Simplify as much as possible or solve. Your answer should not have any negative exponents. So here, I would probably start off by simplifying this as 2 to the 6 minus 9 squared, which is 2 to the negative third squared, which is 2 to the negative sixth, which is 1 over 2 to the sixth. I think 2 to the sixth is reasonable to be able to multiply out. 2 to the sixth is 64. So we can write this as 1 over 64. Either answer is probably acceptable though. Okay, let's do the same kind of thing here. 8 to the 1/3 times 2 to the third. 8 to the 1/3 is 2. So you really have 2 times 2 to the third to the 1/4 power, which is really 2 to the 4th to the 1/4, which is really 2 to the 1, which is just 2. Cool. 3 to the negative 4x equal to 3 to the 6. We can, since the bases are the same, we can just say that negative 4x is equal to 6. X equals 6 divided by negative 4. We should reduce that as negative 3 over 2. Write for natural log of x plus 2 plus 1/3 natural log of 5x minus 1 as a one logarithm. So when you have logarithms added or subtracted together, typically we want to make each of their coefficients positive 1. So I'm going to rewrite this as the natural log of x plus 2 to the 4th plus the natural log of 5x minus 1 to the 1/3. And then since they're added together, I can write that as the natural log of the product, x plus 2 to the 4th times, you can write this as 5x minus 1 to the 1/3, or you can write it as the cube root of 5x minus 1. Either way is technically considered correct. Cool. Page 2. I feel like this word should not be here. I'll fix that. Consider g of x equal to the natural log of x minus 1. Find the equation of the tangent line when x equals 2. So to find the equation of the tangent line, we need two things. We need the coordinate, and we need the slope of the tangent line. So to find the coordinate, we're going to plug in 2 for x here and say that g of 2 is equal to the natural log of 2 minus 1, which is the natural log of 1, which is 0. So our coordinate, our point is 2, 0. Our slope is going to be g prime of 2. Let's find the derivative. G prime of x is 1 over x minus 1. G prime of 2 is going to be 1 over 2 minus 1, which is going to equal to 1. And then the slope, or the equation, is going to be y minus the y coordinate equal to the slope times x minus the x coordinate, which ends up just being y equal to x minus 2. And they want us to, in part B here, graph both the function g of x and the tangent line at the point we just found. So to graph the natural log of x minus 1, we are taking the normal natural log graph and shifting it 1 to the right. So we're going to have a vertical asymptote at x equals 1. And this graph has an intercept at x equal to 2. When we plug in 2, we got y equal to 0. That's also the point of tangency. And then this graph of the natural log here looks like the usual natural log shape. And then the tangent line is the line y equal to x minus 2. It's tangent at that point. We know that y equal to x minus 2 has an x-intercept of 2, and it's going to have a y-intercept of negative 2. Right? If you plug in 0 for x, you get negative 2 for y. So it's going to look like this. I've already labeled that point there. I guess I could label this point here as 0, negative 2. And there you go. That's the graph of natural log of x minus 1 and the graph of its tangent line at the point 2, 0. Moving on to page 3. Problem 3. In each problem, find y prime. This should say y equal to e to the x squared minus 2x. I'll fix that. So we're going to get y prime equal to e to the stuff times the derivative of the stuff, which is 2x minus 2. That's it. here, y prime, the derivative of the natural log of some stuff is 1 over the stuff times the derivative of the stuff, which is 4x cubed plus e to the x. You can write it like this, or you could write it as 4x cubed plus e to the x over x to the 4th plus e to the x. Those don't cancel. Okay, derivative of 4 times 3 to the x, y prime is going to be 4 times the derivative of 3 to the x when the base is different. So the derivative of e to the x is e to the x. The derivative of 3 to the x is 3 to the x times the natural log of the base. So times the natural log of 3. We cannot multiply the 4 times 3. This is not the same as 12 to the x. This is 4 times 3 to the x. Finally, over here, the derivative of x cubed times log base 2 of x, we have to use the product rule. So y prime, and I should write like it. We use product rule is going to be 3x squared times log base 2 of x plus x cubed times the derivative of log base 2 of x. So here, when our base was different, we multiply by the natural log of the base. Here, for a logarithm of the base, it's different. We're going to be dividing by the natural log of the base. So normally, the derivative of the natural log of x would be 1 over x. So here we're going to get 1 over x, and then we're also going to have a natural log of 2 down there. This would simplify, but the problem doesn't ask us to simplify. I would just leave it like this. If you really, really wanted to, though, you could write this part here as x squared over the natural log of 2 because one of those x's would cancel. All right. Problem 4. In each problem below, find/solve for y prime. Answers must be written in simplified fractional form if otherwise. So here, when you've got y equal to the natural log of something gross, you always meant to simplify that using logarithm rules before differentiating. So I'm going to write this as the natural log of x to the 4th times 3 to the x plus the natural log of x plus 1 cubed. And then I'm still going to have y equal to, right, not y prime, y is the natural log of x to the 4th plus the natural log of 3 to the x. Sorry, that should have been a, I made a mistake there. Let's go back. This should be the natural log of x to the 4th times 2 to the x minus, minus natural log of x plus 1 cubed. And then this can simplify as the natural log of x to the 4th plus the natural log of 3 to the x minus, let's bring that 3 down, now 3 natural log of x plus 1. Finally, one more simplification, bring down the powers, 4 times natural log of x plus x times natural log of 3 minus 3 times natural log of x plus 1. Now we're ready to take the derivative. 4 hangs out, the derivative of the natural log of x is 1 over x. Here, x times natural log of 3, natural log of 3 is the constant. And just like the derivative of 7x is 7, the derivative of natural log of 3 times x is just the natural log of 3. Or more generally, the derivative of a constant times a function is the constant times the derivative of the function. The constant hangs out, and the derivative of x is just 1. So we get 1 times natural log of 3, which is natural log of 3. Minus 3 times the derivative of the natural log of what? X plus 1 is 1 over x plus 1. And I suppose if you really want to write this, you can write this as 4 over x. That's the natural log of 3 minus 3 over x plus 1. Here, we are meant to use implicit differentiation because we've got all these x's and y's together. So the derivative, we just differentiate both sides. 4x cubed plus the derivative of the natural log of y is 1 over your stuff times the derivative of your stuff equal to, for x cubed y to the 5th, again, the product rule. The derivative of x cubed is 3x squared times leave the y to the 5th alone plus x cubed. The derivative of y to the 5th is going to be 5 times your stuff to the 4th times the derivative of your stuff. Identify the y primes. Bring those things to one side, everything else to the other side. So it doesn't really matter which side you pick. Let's bring the y prime to the left. So I have 1 over y times y prime minus, I'm going to rewrite this slightly as 5x cubed y to the 4th times y prime equal to 3x squared y to the 5th minus 4x cubed. Factor out the y prime from the side that has the y prime. So you get y prime times 1 over y minus 5x cubed y to the 4th equal to all this junk, 3x squared y to the 5th minus 4x cubed. Finally, y prime equals 3x squared y to the 5th minus 4x cubed over 1 over y minus 5x cubed y to the 4th. I'm not exactly sure what, I'm sorry. what he means by answers usually written in simplified fractional form. But I would say I don't usually like fractions. So if I had to write this in what I would consider a simplified form, I would multiply the top and bottom by y and get 3x squared y to the sixth minus 4x cubed y over 1 over y times y is 1, and then 5x cubed y to the fifth. That to me feels more simplified. Cool. Problem 5. Still solving for x. So I've got 4e to the 9 minus x minus 7 equal to 13. So I need to try to isolate the e to the thing. So first I'm going to add the 7 to both sides and say 4e to the 9 minus x equals 13 plus 7 is 20. Divide both sides by 4. E to the 9 minus x equals 20 divided by 4 is 5. Take the natural log of both sides. 9 minus x equals the natural log of 5. Nothing to be done with that other than leave it as is. So then I'm going to, I don't like multiplying by a negative. I don't know. So you could either do negative x equal to natural log of 5 minus 9, and then multiply both sides with negative 1, and say x equal to negative natural log of 5 plus 9. My preference usually is to bring the x to the other side, and so I'd be like 9 equals natural log of 5 plus x, and then subtract natural log of 5 from both sides and say that 9 minus natural log of 5 equals x. It's the same answer either way. Whichever way you want to do it. I prefer to see it this way. All right. Next question, solve for x. So just like here, we isolated the thing that had the x in it, and generally the exponent here. Here, I'm going to isolate the thing that has the x, the logarithm. So I have 17 minus 5 natural log of x plus 6 equals 2. I'm going to say 17 equals 2 plus 5 natural log of x plus 6. And real tough here, right? 17 minus 5, we can't, right? It's not 17 minus 5, it's 17 minus 5 natural log of x plus 6. So we can't subtract that and get like 12 natural log of x plus 6. Completely, the 5 is permanently attached to the natural log of x. So I'm going to subtract 2 from both sides and say 15 equals 5 natural log of x plus 6. I'm going to divide both sides by 5 to get the natural log of x plus 6, or the natural log of whatever all by itself. And I'm going to rewrite this as my base is e, my power is 3, it's equal to the x plus 6. So then e to the third minus 6 is equal to x. That's as simple as the answer gets. You cannot, I think, you don't have calculators, I don't think. And even if you did, you shouldn't do anything, right? This is the best possible version of this answer. Getting a decimal approximation is less accurate. Graph y equal to 3 natural log of x plus 4, labeling asymptotes, intercepts, and at least 2 points. So the way I find the vertical asymptote is by setting inside of the logarithm equal to 0. So you get x equal to negative 4. You can also just think about shifting 4 left. So that's what the plus 4 does. And then I will point out that, yeah, if I was going to find the x-intercept, I would set the whole thing equal to 0. Normally, it's just going to be 1 to the right of your vertical asymptote because that's usually what the x-intercept is, but it can change based on some stretching. So if we set 3 natural log of x plus 4 equal to 0, let's define the x-intercept. Then natural log of x plus 4 equals 0 divided by 3, which is 0. And e to the 0 equals x plus 4. So that's 1 minus 4 equals x. So yeah, x equals negative 3. Not surprisingly. It's going to have the usual logarithmic shape. My graph might not be perfect. I do notably have a y-intercept. You'll always get a y-intercept if you end up shifting your logarithm graph to the left. You won't get one if you shift it to the right. You won't shift it left or right at all. The y-intercept, though, we're just going to find the y-intercept by setting x equal to 0. The y, which we should find. So if x is 0, then I'm going to say that y is going to be 3 natural log of 0 plus 4. And that's going to be 3 natural log of 4. Which you could write that way, or if you really wanted to, you could write that as the natural log of 4 to the third, which is the natural log of 64. So this point here is 0, comma, I would probably just leave this 3 natural log of 4. And then this point here is negative 3, 0. I guess we labeled at least 2 points. It feels like I'm kind of, no, that's fine. I would just, yeah. Let's just go with that. You could label more, right? I mean, you could like, literally, you could plug in like, for example, if you go, let's say that's 4 to the right, you say that X is 4, and if you plug in 4 here, 3 natural log of 4 plus 4 is 3 natural log of 8. And that's as simple as it is. Right? Label lots of points. All right, moving along. Oh yeah, this one's fun. The tripling time, not doubling time, the tripling time. But for exponential growth and decay problems, the amount of time it takes for the population to double or triple or multiply by whatever factor you want is constant if you have exponential growth and decay. So when I say the tripling time of a population given strictly 5 years, sorry, that means every 5 years the population triples. Assume the amount that is modeled by the exponential growth model. I suppose we need that to say that. Initially, there are 100 triples. Find C, K, and write the exponential growth model. Okay, so we know we have Y equals C e to the KT. And I always like to make this little table here. Time and amount. So we know that at time equals 0, there's 100 turkeys. And we know that 5 years later, there are 300 turkeys. So the population triples. We could even do more here. We could say that 5 more years later, the population triples again. 5 more years later, population triples again, and so on and so on and so on. The reason I'm really doing this is because the answer to a later question. But here we're just going to use these. We only need 2 data points. So if I plug in t equal to 0, then I'm going to get y equal to 100 equal to c e to the k times 0. K times 0 is 0, e to the 0 is 1. So you only just get 100 equal to c. No surprise, c is usually the initial amount you have at time 0. So then we use y equal to 100 e to the kt, and we plug in the second data point. I'm going to say that 300, that's the y value, equals 100 times e to the k times 5. Divide both sides by 100, you get 3 equal to the 5. 3 equal to e to the 5k. Take the natural log of both sides. Natural log of e to the stuff is just the stuff, so natural log of 3 equals 5k. Divide both sides by 5, and get the natural log of 3 divided by 5 equal to k. We found c and k, we still have to write the exponential growth model. Then you just take this equation and you plug in 100 for c and natural log of 0 to 5 for k. So our model is y equal to 100 e to the natural log of 3 over 5 times t. That's your entire experiment. Cool. Rewrite the exponential growth model without using e or natural log. So there's 2 ways you can do this. One way is to kind of just think about what's happening here. So it should look like something like y equal to c times b to the, like, I don't really want to write it this way really, but b to the t over n or something weird like that, where b and n are, so really like n is like the amount of time it takes for the population to double or triple or whatever, and b is the double or tripling. So I'm thinking of this as y equal to 100 times b, so we're tripling, and we're tripling every 5 years. And if you want, you can kind of plug in to see how to happens. So for example, if t equals 0, 0 over 5 is 0, 3 to the 0 is 1, 100 times 1 is 100. Cool, when t is 0, you get 100. If t is 5, 5 over 5 is 1, 3 to the 1 is 1, 100 times 3 is 300. Cool. And let's check one more. If t equals 10, 10 over 5 is 2. 3 squared is 9. 9 times 100 is 900. Yeah, that works. So you can kind of just like make it make sense. It's always going to be, the base is going to be the doubling or tripling. So if it's doubling every 5 years, the base would be 2. If it's tripling every 5 years, the base would be 3. If it's quadrupling every 5 years, the base would be 4. And then the 5 there is how many years it takes for the doubling or tripling to happen. The other way to get there is to use this formula and rewrite it. You'll say, well, I'm going to write this as y equal to 100. And now here's where the trickiness happens. I'm going to rewrite this as 1/5, sorry, not 1/5, t/5 times the natural log of 3. But I'm going to use the rules of logarithms to say, oh yeah, if you have a power times the natural log of x, notice I'm talking about the power already. The log rule is that's natural log of x to that power. So I'm going to bring this t over 5 up as the power on the 3 there. So I'm gonna rewrite this as y equal to 100. I missed the e. Sorry, that's terrible. Oh, let me rewrite this. Sorry, it's awful. It's 100 e to the t over 5 times natural log of 3. Terrible. So then that t over 5 is going to come up as the power of 3. And then I've got 100 times e to the natural log of 3 to the t over 5. And then e to the natural log of something is just the something. So this becomes y equal to 100 times e to the natural log of 3 to the t over 5 is just 3 to the t over 5. And that's it. Again, I'm going to say, if you have a constant times something to a power, you cannot multiply those things together. This is not the same as 300 to the t over 5. This is the safest, only way to write it. Draw a sketch of the amount of turkeys as a function of time, including at least 3 nice points on your graph. I've already got a bunch of nice points here, so I'm going to do that. The graph should not go left. Oh, sorry, you can't see that. Apologies. He created it by views when here. So I'll point out here that the graph shouldn't go left of t equals 0. So this is t, this is y. We should be starting at like 0, 100. And then it's going to get bigger, bigger, bigger. So every 5 years, population triples. My graph is not going to be to scale, but it's going to be, exponential. Then I would label points, even though the labeling might not look wonderful. That's going to be 5, 300. That's going to be 10, 900. That's going to be 15, 2700. The graph does not need to be to scale. As long as it's got the right kind of exponential shape and labeled points correctly, you're fine. But we should not include that left-hand part there. The tail going down. All right, let's look at problem 7a. It's like 3 pages, problem 7 here. Lots of integration. Okay. Integral of secant squared of natural log of x over x dx. I see an obvious u sub. U is the natural log of x. Du is 1 over x dx. I can rewrite this as the integral of secant squared of natural log of x times 1 over x dx. The 1 over x dx is my du. The natural log of x is my u. This becomes the integral of secant squared of u du. The antiderivative of secant squared of u is tangent of u. The derivative of tangent of u is secant squared of u. But then we started with x's, so we have to end with x's with an indefinite interval, which most of these are. Our final answer is tangent of, plug back in that u is equal to natural log of x. You get tangent of natural log of x. Let's see. All right. Integral of x squared minus 5 over x plus 2, I believe. Technically, you can do a u sub here. I would probably opt to do polynomial division. I might show both ways, depending on what space I have. So I would do this as polynomial division. I would do x squared. I'm going to write plus 0x minus 5 divided by x plus 2. X times x is x squared. You get x squared plus 2x. Subtract. 0 minus 2 is negative 2x minus 5. X times negative 2 is equal to negative 2x. So I get negative 2x, and negative 2 is negative 4. Subtract, and you get negative 5 plus 4, which is negative 5. So I can rewrite this as the integral of the quotient x minus 2 plus the remainder negative 1 over the divisor x plus 2. And then that's just going to be x squared over 2 minus 2x minus the natural log of the absolute value of x plus 2. Let's see. Alternatively, I think I can squeeze this in here. You can do this with a u sub and a back sub. I don't think this is the better way to go, but it is a way to go if you see it that way. So I would let u equal x plus 2. Du is dx. And solving for x here to plug back into the x squared, u minus 2 is equal to x. So then this integral of x squared minus 5 over x plus 2 dx becomes, if you're me, you're always thinking about making the du dx changeover happen first. Here it's super easy. dx is just equal to du. So I'm going to get a du at the end here. And the denominator is just my u. The numerator is, instead of x squared minus 5, it's going to be u minus 2 squared minus 5. Multiply at the top. You're going to get the integral of u squared minus 4u plus 4 minus 5 is minus 1. Sorry, I'm going to use my 4's don't look different, but different enough. Divide each thing by u. So you get u squared divided by u. 4u divided by u is minus 4. And minus 1 over u. Integrate. We're going to get u squared over 2 minus 4u minus natural value of the absolute value of u plus c. And finally plug back in, and we get x plus 2 squared over 2 minus 4 times x plus 2 minus the natural value of the absolute value of x plus 2. Let's see. Are these answers exactly the same? No, they're not. But are they the same enough? Yes, they are. They differ by a constant. If you multiply this out, you would have x squared over 2. You'd have 4x over 2, which is 2x. And 2x and minus the 4x would give you the negative 2x. And then you'd have 4 over 2 minus 8, which would give you a 2 minus 8, which is negative 6. But the negative 6 here is a constant, and it's okay for these to differ by a constant. So either way is fine. All right, let's look at part C. Solve the initial value problem, f prime equals 3x squared minus 4x with the initial condition f of 3 equals to 14. So to find f of x, we're going to anti-differentiate. The antiderivative of 3x squared minus 4x is 3x cubed over 3, which is x cubed, minus 4x squared over 2, which is 2x squared, plus c. Plug in 3. We get 27 minus 2 times 9, plus c, and that should equal 14. Solve for c. 27 minus 18 is 9, so 9 plus c equals 14. C is going to equal 14 minus 5, 9, which is 5. And then you do have to go back and plug this in and say, okay, great. That means that f of x is going to be x cubed minus 2x squared plus 5. And that is our final answer. Cool. 7b. Integral of x to the 4th over 3 minus x to the 5th to the 9th. To me, this feels like an obvious u sub. Let me u equal 3 minus x to the 5th. The du is negative 5x to the 4th dx. I would, since I see an x to the 4th dx, I would divide both sides by negative 5, or multiply by negative 1/5 and say negative 1/5, and du equals x to the 4th dx. I'm always a fan of kind of writing it out, so I would rewrite this as the integral of 1 over 3 minus x to the 5th to the 9th times x to the 4th dx. We're always making sure that the dx stuff changes into the du stuff first. So this is equal to negative 1/5 du. And this is going to be my u right there. So this integral is going to become the integral of 1 over u to the 9th times negative 1/5 du. I would normally just bring that negative 1/5 out in front from the get-go. So I would like to rewrite this as negative 1/5 integral of u to the negative 9th. That's going to be negative 1/5 u to the negative 8 divided by negative 8 plus c. Simplifying here, 5 times 8 is 40. So I'm going to get negative times negative positive. I'm going to get 1 over 40 times u, which was 3 minus x to the 5th to the negative 8. And if you don't like negative exponents, which I think he kind of doesn't, you could alternatively write this as 1 over 40 times 3 minus x to the 5th to be positive 8. Let's see. Cool. 4x over x plus 1 squared. You could do partial fractions here. That's not what I would do. This is a better seen as a u sub of the back sub. We're going to use kind of like the problem we just did where we did division and then did u sub of the back sub. So use x plus 1, du is dx, and then x equals u minus 1. I'm going to rewrite this as the integral of dx is just du. How nice. The denominator is u squared. The numerator is 4 times u minus 1. I probably would have just factored out the 4 in the first place. So I'm gonna write this as 4 times the integral of u over u squared minus 1 over u squared. Simplify. And 4 still out in front. I've got u over u squared, which is 1 over u, and minus 1 over u squared, which I do like to write things that aren't just u to the -1 as whatever they are, it's u to the -2. And to differentiate, you get 4 times the natural log of the opposite value of u minus u to the -1 divided by -1. Which equals, so I want to point out that minus u to the -1 over -1 is plus u to the -1, which is plus 1 over u. This is 4 natural log of the absolute value of u plus 4 times 1 over u, plus c. Finally, plugging back in, we can 4 times the natural log of the absolute value of x plus 1 plus 4 over x plus 1 plus c. You can also write that as 4 times 1 over x plus 1, but it's necessary. All right, next problem here. I see a u sub, u equal to e to the 3x plus 2. du is going to be e to the 3x times 3 times dx. 1/3 du equals e to the 3x dx. So I can rewrite this integral as 1 over e to the 3x plus 2 times e to the 3x dx. E to the 3x dx is equal to 1/3 du. That bottom part there is u. And then we get the integral of 1 over u times 1/3 du. 1/3 on the front. That's going to be 1/3 natural log of the absolute value of u times c, which is going to be 1/3 natural log of the absolute value of e to the 3x plus 2. Let's see. Cool. 7C. So I feel like 7C part A here is meant to be really, really obviously a new substitution. If you let u equal x cubed plus secant of x, your du is exactly 3x squared plus secant of x tangent of x dx. So this integral becomes exactly the integral of du over u, which if you prefer is 1 over u du, which is the natural log of the absolute value of u plus c, which is exactly the natural log of the absolute value of x cubed plus secant of x plus c. This problem here requires us to do something first. The shortcut, I think, is to multiply the top and bottom by e to the opposite sign power. So I'm going to rewrite this as the integral of 1 over 1 plus 2 e to the -3x times e to the 3x over e to the 3x. And that's going to be the integral of e to the 3x over 1 plus, sorry, over e to the 3x plus 2 e to the -3x times e to the 3x is 2 times e to the 0, which is just 2. Alternatively, if you don't like that, you can start off by rewriting this as the integral of 1 over 1 plus 2 over e to the 3x. And then you want to get rid of that denominator by multiplying the top by e to the 3x and the bottom by e to the 3x, which gets you to the same place. Either way, this is actually the problem that we just did on the previous page. Right? We did exactly integral of e to the 3x over e to the 3x plus 2, and the answer was equal to 1/3 natural log of the absolute value of e to the 3x plus 2. I don't think that would happen on your exam, but I kind of saw an opportunity to make that kind of interesting, I thought. So I decided to, yeah, those are really the same because, right? So this integral and this integral are the same integral. You just look a bit different. Okay, the last one here on this page. Integral of x times secant squared x, we have some integration by parts. And I did not see a lot of integration by parts on this exam. But I did see one. So we're going to let u equal x, du equal dx. dv has to be the rest, which is secant squared of x dx. And v is going to be the antiderivative of secant squared, which is tangent of x. Rewriting this, we get u times v minus the integral of v du. Now, I do think you're expected to know the integral of tangent. If you forgot it, you could rewrite this as x times tangent of x minus the integral of sine x over cosine x. And then we'd be like, oh yeah, the integral of sine x over cosine x, if you let u equal cosine x, du is negative sine x dx. The negative du equals positive sine x dx, so this becomes the integral of negative du over u, which is negative natural log of the absolute value of u, which is negative natural log of the absolute value of cosine of x. This ends up becoming x times tangent of x minus negative natural log of the absolute value of cosine of x. Let's see. So the minus the negative became a positive. If that wasn't clear. All right, let's look at problem 8. I should point out for problem 8, he says in big bold letters, in these problems, sketch and set up only. Do not solve. More than one integral may be needed. Label appropriately and clearly indicate the regions. So, sketch the region bounded by y equals 3x and y equals 4x minus x squared. And set up only the integral of this area and also the volume in solid form by revolving this region about the x-axis. I'm going to draw this. To draw this, I think you should find where they intersect. If you set 3x equal to 4x minus x squared, you get x squared minus x equal to 0. You get x times x minus 1 equal to 0. So you get x equal to 0 and x equal to 1. If x is 0, y is 0. If x is 1, y is going to be 3. So it's kind of like this. Y equals 3x is a straight line. Looks like that. And then y equal to 4x minus x squared is a downward opening parabola. And I feel like something good. I feel like, did I do this? I'm making a mistake of some sort. 3x times 1. I just know that. I'm curious about how this looks. I thought I knew how this looked. 4x minus x squared. We have intercepts at x equal to 0 and x equal to 4. 2 3 times 4. Yeah, I should. I might need to. I'm going to check out the graph here real quick. Sorry about that. I feel like I thought about this problem more convincingly. Let me go and look at the graph. Just because I feel like I should know how this looks, but I feel like I think I'm thinking of it wrong. So I'm going to graph it real quick. We got y equal to 4x minus x squared. And I guess I should share this with you so you can see what I'm doing. I might need to change this problem. Okay, and then the other graph is y equal to 3x. I feel like this. No, I guess they're intersect. I guess, yeah, okay. I guess that's not at all not what I was thinking. I was just imagining. I feel like what I really wanted to do was have it like intersect here instead. Like, but, oh well. Yeah. Yeah. I guess I should have picked y equals x, such as like, oh well, still works out just fine. So yeah. This here, division. Okay. So might be intersect at 1. It's kind of doing something like it's not the best thing I've ever come up with. Sorry. But there's your region right there. So if I want to find the area is going to equal the integral from 0 to 1 of the top function, which is parabola, minus the bottom function, which is the straight line. Find the volume that you get by revolving this around. It's going to be still the integral from 0 to 1 pi times the outer radius squared minus the inner radius. squared. Kind of it. There's not a lot more to it. Again, I do wish I'd pick a slightly better graph situation. I could draw this better. If I was trying to draw this better, I would be better. So when x is 0, they're both 0. When x is 1, they're both equal to 3. Straight line is doing this sort of deal. And the parabola is not my best parabola. Yeah, the parabola, it's the point 0, 0, and 4x minus x squared. Yeah, like that. And then we also have the point 2 comma 6. 2 comma 6, no, 2 comma 4. Right, 8 minus 4, yeah. Here are the 3 points on the parabola, so doing this kind of deal. It's a little bit better, and then you can move on that way. Okay, not in love with this, but sometimes problems aren't. To the next one. Sketch the region bounded by y equal to root x, y equal to 6 minus x, and x equal to 0, and set up only the same intervals for volume and area. So, sketch this stuff. You know what y equals root x looks like? It looks like this. Y equal to 6 minus x is a line that goes through the points. The intercepts 0, 6 and 6, 0. And x equals 0 is the y-axis. We're looking at this region here. And taking, first one, find the area. The area is going to be the integral of the top function minus the bottom function. From as far left as, well, clearly as far left as 0 to as far right as whatever that point of intersection is right there. Find the point of intersection, we're going to set the square root of x equal to 6 minus x. Now, you could actually solve this by squaring both sides and using algebra, or you could just guess. I'm going to guess the nice number to take the square root of. If x equals 0, you're getting 0 equal to 6 minus 0. Nope. If x equals 1, the square root of 1 is 1, equals 6 minus 1. Nope. If x equals 4, the square root of 4 is 2, equals 6 minus 4. Yep. So x equals 4 is the place where they intersect. That point there is 4 comma 2. So there's your area. Find the volume of revolution. Again, we're using this washer method like we did in the previous one. I didn't state explicitly because I was too caught up in how terrible my graph was. And we're thinking about revolving this around the x-axis. So when you revolve this around the x-axis, you get something that looks like this. You don't have to draw this picture for this problem. I'm just drawing it so you can see that, oh yeah, you've got some inner radius and some outer radius. And the volume is the integral of the big circle, pi times big R squared, minus the volume of the little circle, pi times little r squared, times the thickness, dx, from as far left as 0 to as far right as 4. I could maybe read in this script instead. Get a bigger motion. In this case, that's going to be pi times the integral from 0 to 4 of the large radius, which is 6 minus x squared, times your little radius, which is the square root of x. I leave it like that. Average value. Find the average value of a function, you just integrate that function. And then you divide by the length of the integral. So it's going to be 1 over 10 minus 1, so 1 over 9, times the integral from 1 to 10 of 6x squared. That's going to be 1/9. I don't love this kind of thing. 1/9 times the integral of 6x squared is 6x cubed over 3. 1 to 10. 6 over 3 is 2. So I'm going to rewrite this as 2/9 times x cubed from 1 to 10. Putting in 10, you get 2/9 times 10 cubed, which is 1,000. Minus 2/9 times 1, which is 2/9. I don't know if we can simplify this. 2,000 minus 2 is 1,998 divided by 9. That is divisible by 9. You can see that because the numbers here add up to 27. Percent out to 9. If you really want to divide this by 9, you're going to get, I don't know, 200 something. I don't really feel, I mean, I guess I should. I can do it the long way. 9 goes in 19 two times, 15, and then 9 times, 8, 222. What a nice number. Integral of 5x cosine of 4x squared is a mixture. We're going to use substitution because the mu equals 4x squared gives you some multiple of x. We don't really care about the coefficient. So I'm going to say that 1/8 du equals x dx. And rewrite the integral as 5 times the integral of cosine of 4x squared times x dx. So then my x dx is 1/8 du, and that's going to be equal to, I'm going to put the 8th out in front, 5/8 integral of cosine of u, u. Antiderivative of cosine of u is sine of u. And then finally, we get 5/8 times sine of 4x squared. Next problem is, I think, obviously a partial fraction problem. If you see a rational function like this and they've already factored the denominator for you, it's a pretty good bet. It's a partial fraction. I think it's a partial fraction problem. I feel like we might not have quite enough room here. I might have to grab a piece of paper. But I'm going to start off by setting up the partial fraction decomposition. 2x squared minus x plus 1 over x times x minus 1 squared equals a over x plus b over x minus 1 squared plus c over x minus 1. Multiply both sides of the common denominator. On the left-hand side, we're going to get 2x squared minus x plus 1. On the right, if you multiply a over x by x times x minus 1 squared, you get a times x minus 1 squared. B over x minus 1 squared times x minus 1 squared is b times x. And finally, c over x minus 1 times x minus x minus 1 squared is going to be c times x minus 1 squared, of course. Pick the convenient values of x. X equal to 0. On the left-hand side, you get 0 minus 0 plus 1. On the right-hand side, you get a times negative 1 squared plus 0 plus 0. So a is 1. X equal to positive 1 is the other convenient value. 2 minus 1 plus 1 is 2. A times 0, b times 1, c times 0. I like to pick coefficients. So then I would say the highest power is x squared. On the left, I have a 2x squared. On the right, I have an a times x squared. And then we have a c times x squared. So I share this with them. So then 2 equals a plus c. So c equals 1. Since a equals 1. So then we can rewrite this integral as equal to the integral of 1 over x plus 2 over x minus 1 squared plus 1 over x minus 1. I might rewrite this as 1 over x plus 2 times x minus 1 to the negative second plus 1 over x minus 1. So we're going to get the natural log of the absolute value of x plus 2 times x minus 1 to the negative first divided by negative 1 plus the natural log of the absolute value of x minus 1. If it were me, I would like to rewrite this as the natural log of the absolute value of x minus 2 over x minus 1 plus the natural log of the absolute value of x minus 1. Cool. Cool. Midpoint rule. Okay. I think this problem gives the draw pictures. So the idea here is that we've got some function from 1 to 3. I don't really need to be perfect. And if I plug in 1, 1 plus 1 is 2. We plug in 3, 9 plus 1 is 10. I don't really want to draw it like that crazy. I might have wanted to draw it curvier than that though. So I'm going to go from 1 to 3. I'm going to break this up into 4 rectangles. So my delta x is 3 minus 1, 4, which is 1/2. So I got 1/2, 1. Okay. So then my rectangle, so I'm breaking this up like this. And then for each of those, I'm using the midpoint to find the height. So if this is 1 1/2, right, that's 1 plus 1/2, 2, that's half between 2 and 3 is 5/2. Then the midpoint of 1 and 3/2 is going to be 1 plus 3/2 divided by 2. It's going to be, well, I'm going to write them up as fourths. 1 is 4/4. 3/2 is 6/4. And the halfway point is 5/4. So my midpoints are 5/4, and the next one is 1/2 away. So 5/4 plus 1/2, 5/4 plus 2/4 is 7/4, and then 9/4, and then 11/4. So then my midpoint rule using 4 rectangles is going to equal my base, which is 1/2 times all my heights. F of 5/4 plus F of 7/4 plus F of 9/4 plus F of 11/4. Which is kind of gross. It's going to be 1/2 times 5/4 squared plus 1 plus 7/4 squared plus 1 plus 9/4 squared plus 1 plus 11/4 squared plus 1. I would not simplify this unless I was told I had to. We could simplify it 1/2 times the gross. 1 plus 1 plus 1 plus 1 is 4. And then 5/4 is 25/4. 7/4 is 49/4. 9/4 is 9. So 5/4 squared is 25/16. 7/4 squared is 49/16. 9/4 squared is 81/16. And 11/4 squared is 121/16. And then you can do more with this. Yeah. 1/2 times 4 plus gross. 40 plus 80 is 120, plus 1 plus 9 is 130, plus 121 is 251, plus 25 is 276. I don't want to get there. Okay. Same problem with trapezoid rule. So I'm going to draw a picture again. I'm going to try and make it look a little bit nicer this time. 1, 3, same kind of function, and then everything is like in 4/7 intervals. There's 3/2, there's 2, there's 5/2. Then we're drawing trapezoids. So trapezoids to me never look good. I always feel like they're too close to what the function looks like. Trapezoid you will use for 7 intervals is going to be your delta x over 2, and then it's the 1, 2, 2, 2, 1 pattern. In this case, so it's going to be delta x is my 1/2 over 2, and then it's going to be 1 times f of 1 plus 2 times f of 3/2 plus 2 times f of 2 plus 2 times f of 5/2 plus 1 times f of 3. Squeeze that in there. The t sub 4 is going to be 1/4 times f of 1, which is 1 squared plus 1. Right, my function is still x squared plus 1. F of x squared plus 1. So f of 1 is going to be 2. And then 2 times f of 3/2 is going to be 9/4 plus 1. And then 2 times f of 2 is going to be 4 plus 1. And then 2 times f of 5/2 is going to be 25/4 plus 1. And then finally, 1 times f of 3 is going to be 1 times 10. Again, we could simplify here a bit. 1/4 times, let's see, 2 plus 10 plus 10 is 22. And then 2 times 9/4 plus 1, that's going to be 13/4, so 13/2. And then 2 times 25/4 plus 1, that's 29/4, so 29/2. And this simplifies to 13 plus 1, that's 42 divided by 2 is 21. We get 1/4 times 22 plus 21, 43. Estimate the error bound. So the error bound, we know that the error, I might not pick the function. The absolute value of error is less than or equal to b minus a. B minus a cubed over 12 times n squared times the maximum of the second derivative of the interval. So, geez, I might have picked a bad function for this, but oh well. So the maximum of the second derivative, the first derivative is 2x, the second derivative is 2. So the maximum of the second, right, if your function is x squared plus 1, then f prime is 2x, and f double prime is 2. So the maximum of the second derivative is 2, because it's always 2. So this is going to be equal to, let's see, 2 cubed is 8 times 2 is 16 over 12 times 4 squared. Those cancel and you get 1/12. The error of our estimate is less than or equal to 1/12. Nice. All right. Converges, diverges. Yeah. So here we see that this integral infinity is the problem. I'm gonna pause real quick. All right, so improper integrals, you're gonna have to do the limit. Infinity is always a problem. So we're gonna rewrite this as the limit of b approaches infinity, and the integral from e to b of 1 over x natural log of x. I will also point out, if this integral had a different lower limit, like 1, that would also be a problem because natural log of 1 is undefined. 0 would also be a problem. So make sure, I think in one of his practice problems, he does have one where both the infinity problem and the lower limit is also problematic. So just look out for that. So we're so integrating this, since the integral here is a little bit less than straightforward, I'm gonna do the indefinite integral off to the side. The integral of 1 over x natural log of x is u sub, u equals natural log of x, du is 1 over x dx. This becomes the integral of 1 over natural log of x times 1 over x dx. There's your du, and the integral of 1 over u is the natural log of the absolute value, which is the natural log of the absolute value of the natural log of x. So then this is going to equal the limit, if b goes to infinity. The integral of this is the natural log of the natural log, so the natural log of the absolute value of the natural log of x from b to b. That's going to be the limit if b goes to infinity of the natural log. You don't technically need the absolute value here because the natural log of b is positive if b is going to infinity. Minus the natural log of e is positive, so we don't need to absolutize it. Totally fine to write them. That's going to be, so that's going to be 1, that's going to be 0. So you really got the limit, b goes to infinity, as the natural log of the natural log of b. As b gets infinitely large, the natural log of b goes to infinity, and as that goes to infinity, the natural log of that also goes to infinity. It's the limit to infinity, which means the integral diverges. Cool. The next one. I did not give one. So same sort of deal here. We have an infinity. So we're going to rewrite this as the limit. B goes to infinity. The interval from 0 to b of 3x squared over 1 plus x cubed squared. Again, this requires a u sub. U would be 1 plus x cubed. Du is exactly 3x squared dx. This is going to become the integral of du over u squared, which is the same as the integral of u to the negative second du, which becomes -1, sorry, negative u to the negative first, or u to the negative first divided by -1, which is really the same as -1. This is going to be, which is -1 over 1 plus x cubed. So this is going to be equal to the limit, if b goes to infinity, -1 over 1 plus x cubed from 0 to b. So then that's going to be the limit as b goes to infinity of negative 1 over 1 plus b cubed minus negative 1 over 1 plus 0 cubed. As b goes to infinity, 1 over 1 plus b cubed, that's going to get pretty small. You're left with positive 1 over 1 plus 0, which is just 1. This converges, and it converges to 1. I will point out, because I think it's worth pointing out, that this could also be a good example of a function that is a, oh my gosh, that's the word I'm looking for. That is a PDF on the interval from 0 to infinity. So since this, right, since the interval is equal to 1, and this function is always positive, this could be a PDF. So I should have asked, so if someone had asked the question, show that this, so if someone had said, show that f of x equal to 3x squared over 1 plus x cubed squared on the interval from 0 to infinity is a PDF, a probability density function. This is how you would do it. You would take the integral of it over its interval, so being improper, and then you would show that it was equal to 1, and that's what you would need to show something. Yeah, kind of cool. That'd be a good problem. I like that. I will point out also, it'd be hard to find the mean here because the mean, yeah, the mean would be really hard. I don't think this would not be a good question to find the mean and variance for, because then the interval of x times this, I think, is really, really challenging, maybe even impossible. All right, probability stuff. Consider the experiment of rolling 2 4-sided dice. Let the random variable x be the total shown by both dice. Find the sample space. So the things that can happen, you can roll 2 1s. So really, I would write down both, like, so I've got D1 and D2, right? So you either get a 1, 2, 3, 4 for D1 or 1, 2, 3, 4 for D2. The sample space, I don't remember if we've been using the omega notation in this class, but omega is often the way of writing the sample space. Is you can get, well, you get a 1 and 1, which adds to 2, 1 and 2, which adds to 3, 1 and 3, which adds to 4, 1 and 4, which adds to 5, 2 and 4, 3 and 4, 4 and 4. I think those are all the possibilities. Right, so if you roll 2 dice, the sum of those 2 dice can either be a 2, 3, 4, 5, 6, 7, or 8. That's it. I've never done the frequency and probability distribution plots. I don't really get the point of those, but fine. Guess what we're going for. So for the frequency, I feel like these are really the same, but like one's a fraction, one's not. So the frequency, so the x, so right, so x can either be, I really don't like making these charts. I feel like it's really not fun. We can either have 2, 3, 4, 5, 6, 7, 8. And the value, so you can get 2 one way. You can get 3 2 ways, either 1 and a 2 or 2 and a 1. You can get 4 3 ways. So if it were me, I would making this little table over here. You can get 1 and 1, 2, 1 and 2, 1 and 3, 1 and 4, 2 1, 2 2, 2 3, 2 4, 3 1, 2 2, 3 3, 3 4, 4 1, 4 2, 4 2. So I can get 2 one way, I can get 3 2 ways, I can get 4 3 ways. I can get 5 4 ways. Sorry. And I can get 6 3 ways, 7 2 ways, and get 8 1 way. And then the probability distribution plot should look the same as that, except it should be fractions. So literally it's going to look exactly the same as far as I'm concerned. Except now this is frequency f of x, the probability p of x. The probability of getting a 2 is 1/16 because there are 16 total possibilities. It'd be 1/16, 2/16, 3/16, 4/16. Sorry, this is so small. You can kind of see that. I'll zoom for a minute here. All right, 1/16, 2/16, 3/16, 4/16. So probability of a 2 is 1/16. Probability of a 3 is 2/16. Probability of 4 is 3/16. I might be doing this wrong as far as like keys concerned. Probability of a 5 is going to be 4/16. I don't know why I wrote 5/16 on there. I think I just got carried away. Probably 6 is 3/16. Probably 7 is 2/16. Probably 5 is 8 is 1/16. If you add this up, 1 plus 2 plus 3 plus 4 plus 3 plus 2 plus 1. I feel like that. Oh yeah. This is not right. Sorry. 1 plus 2 plus 3 plus 4. Yeah, that should be 16. Yeah, 16. Yeah. So it's 1/16 plus 2/16 plus 3/16 plus 4/16 plus 3/16 plus 2/16 plus 1/16 does add up to 16/16. The mean, aka the expected value, which is the expected value, is just the sum of each value of x times the probability of that value of x. That's going to be, the value is 2 times 1/16. I should give myself a problem here. It's going to be 2 times 1/16 plus 3 times 2/16 plus 4 times 3/16 plus 5 times 4/16 plus 6 times 3/16 plus 7 times 2/16 plus 8 times 1/16, which is going to be 2 plus 6 plus 12 plus 20 plus 18 plus 14 plus 8, all divided by 16. The top part adds up to 80, I believe. Let's see, 8, 20, 40, 58, 68, 72, 80. Yep, and 80 divided by 16 is 5. And then, expect the variance, I would use this formula. It's the sum of x squared times the probability of x minus the mean squared. In this case, it's going to be, this one's going to get a little bit ugly. So I'm going to write this out as, so 2 squared. So 4 times 1/16 plus 9 times 2/16 plus 16 times 3/16 plus 25 times 4/16 plus 36 times 3/16 plus 49 times 2/16 plus 64 times 1/16 minus 5 squared. Can we simplify this? Probably. Sure. 4 times 1, 9 times 2, 16 times 3, 25 times 4, 36 times 3 is 108, 49 times 2 is 98, 64 times 1 is 50, minus 25. And then let's see if we calculate this. Let's see. 4 plus 18 is 22, plus 48 is 70, plus 100 is 170, 278, 376, 4 is 80, plus 6 is 440. 440 over 16 becomes 100, sorry, 110 over 4. And then that's going to be 55 over 2 minus 50 over 2 plus 5 over 2. I'm sorry, sorry, I didn't see any of that. I apologize. Let me, sorry. Variance is, so the x squareds, I'm squaring each of those x's. 2, 3, 4, 5, 6, 7, 8, 4, 9, 16, 25, 30, 39, multiply by the same probabilities, and then subtracting the mean square. I simplified the top, so it's 4 times 1, 2, 3, 4, 2, 1, all that, and then the rest is just the math of mapping it out. The top, I believe, adds up to 440, double check. 22 plus 48 is 60 plus 10 is 70, 170, 278 plus essentially 100 minus 2, so 378 minus 236 plus 4 is 380 plus 60 is 420. Reduces to 104, which is and then the standard deviation would be the square root of that. All right, these last couple problems here. To show this defined in the PDF, you have to do the limit. You have to do the integral 0 to infinity of 7/4 e to the negative 7/4 x dx. And then it's going to be an improper integral. We know the answer should be 4/7 x. So that's going to be the limit. B goes to infinity. The integral of e to the, that's an e to the negative 7/4 x. I know it looks terrible. The integral of e to the negative 7/4 x is e to the negative 7/4 x divided by negative 7/4. So we're going to get 7/4 e to the negative 7/4 x divided by negative 7/4. 0 b 7/4 and the negative 7/4 cancel, except for the negative 1. So we're really left with the limit of b goes to infinity of negative e to the negative 7/4 x. I know I said before that we knew the mean was going to be 4/7. I thought what this problem was asking, so apologies. This problem is asking us to show it, define the PDF, and we show that the n was equal to 1. That's going to be the limit. B goes to infinity of negative e to the negative 7/4 b minus negative e to the 0. This ends up being the limit if b goes to infinity of, I'm going to write this as negative 1 over e to the 7/4 b plus 1. As b goes to infinity, e to the 7/4 b goes to infinity, and 1 over infinity goes to 0. So we wanted. This question is slightly different. Find the value of cases of this integral. So this function is a PDF. So we would do integral from 0 to 2 of k times 2x minus x squared dx, and we set that equal to 1. That's all for k. So integrating, we're going to get k times the integral of 2x is x squared. The integral of x squared is x squared over 3. X cubed over 3 from 0 to 2. So we have k times 2 squared minus 2 cubed over 3 minus 0 minus 0 equal to 1. So k times 4 minus 8 thirds. 1. So k times 12 thirds minus 8 thirds is 4 thirds equals 1. So k equals 1 over 4 thirds, which is 3 thirds. Cool. Last problem. Get the median for the PDF of x into the 7/4 e to the negative 7/4 x. So to find the median, we're going to set either the integral from 0 to m equal to 1/2, or the integral from m to infinity equal to 1/2. Definitely use one. We're going to set the integral from 0 to m of 7/4 e to the negative 7/4 x dx equal to 1/2 and solve for m. We already know what the antiderivative of this is. It's going to be negative e to the negative 7/4 x from 0 to m equal to 1/2. Plug in the m and the 0, so you're going to get negative e to the negative 7/4 m minus negative e to the 0 equal to 1/2. Take negative e to the negative 7/4 m plus 1 equal to 1/2. I see that this part has to be essentially equal to negative 1/2, because negative 1/2 plus 1 equals 1/2. So I need that e to the negative 7/4 m is equal to 1. So then negative 7/4 m equals the natural log of 1/2, which is equal to the negative natural log of 2, which means m is equal to 4/7 times the natural log of 2. Here we're being asked to find the mean and the mean. So find the mean, it's the integral of x times f of x from 0 to 2. That's going to be the integral from 0 to 2 of, and we found k to be equal to, I believe it was 4/3 or 3/4. 3/4. Give me x, it's 3/4, it's 2x minus x squared, which is equal to 3/4 integral 0 to 2 of 2x squared minus x cubed. X we integrate. We get 2x cubed over 3 minus x squared over 4. We get 2 again. 3/4 times 3/4 times 2 times 8 over 3 minus 16 over 4. Sure, it's end up equaling 3/4 times 16 times 1/3 minus 1/4. That's 4/12 minus 3/12, so we get 3/4 times 16 times 4/12 minus 3/12 is 1/12. End up with 3/4 times 16/12, which ends up being 1. The 16 over 4 is 4. 3 over 12 is 4, and 4 over 4 is 1. So the mean is 1. Which, if you know what the graph of this looks like, which is surprising because the graph of this has symmetry about the line x equals 1. Like the graph of this parabola essentially looks like this. It's not surprising. Oh, sorry. The graph of the parabola looks like this. And there is symmetry about the line x equals 1. It's not surprising that the mean is right in the middle. It's also going to be not surprising that the median is also going to be 1. If we set the integral from 0 to m of our function, 3/4 2x minus x squared, the x equal to 1/2, that's going to give me that 3/4, integrate that, you get x squared minus x cubed over 3 from 0 to m equals 1/2. I multiply both sides by 4/3 to get m squared minus m cubed over 3 equal to 1/2 times 4/3 is going to be 2/3. Solving this is a pain. I multiply everything by 3. So I'm going to get 3m squared minus m cubed equal to 2. Bring everything to the right hand side, and we get 0 equal to m cubed minus 3m squared plus 2. And if you just guess, you can see that m equal to 1 is a solution because 1 minus 3 plus 2 is equal to 0. So this does factor as m minus 1 times m squared, and then you have the plus, let's see. So m cubed minus m squared is going to be minus 2m squared, minus 2m, and you get a net plus 2m. Minus 2m. And that's how that would factor. I mean, this doesn't have any other nice solutions. So m, which is the same as the, which isn't always true, but it is true when you have symmetry like this. So, cool. All right, that's the solutions. I got to run, so I got to kind of drop in, but hopefully those are all correct. There's a few small corrections I need to make in the practice final, but they're not a big deal if you have the current version. Yeah, good luck on your final on Thursday. Feel free to email me with any questions or put my drop in. You know, I'm always happy to help. I'll see you on the 16th. Bye.